I'm here with Valeriy from MariaDB and wanted to talk to him about his upcoming session at Percona Live Online. So Valeriy, your talk is on dynamic tracing for finding and solving MariaDB and MySQL performance problems on Linux. From what I understand, this is about finding those really difficult to find problems in MySQL, MariaDB, and on Linux. Can you tell us a little bit about the talk?
Yeah, basically, yes. The idea is that modern Linux systems for actually almost 10 years already provide means to solve performance problems in the Linux kernel itself and in absolutely any software that runs there, independently of the level of instrumentation that software provides. In case of MySQL, we have a quite, especially modern versions, quite detailed instrumentation already added in form of performance schema. And for the majority of use cases, for simple cases, for developers, for understanding where a single query spend the time and why these tracing and performance counters provided by performance schema allows quite easily with familiar SQL statements to find out what's going on. Unfortunately, it's not always the case when we speak about older versions of MySQL, about MySQL forks like MariaDB, where performance schema is a bit outdated comparing to the recent findings. We may do not have performance schema enabled from the very beginning at customer side. So while in the modeling environment, we can solve a huge number of practical problems with performance schema, when you go on site or when you have to debug live with customer, you may find out the performance schema is not there. One thing. Another thing is that third-party storage engines not originating from Oracle or Percona, plugins like Galera, for example, even if they are instrumented, they are much less instrumented.
Oh, okay.
And even if everything is instrumented, you have to assume what you are looking for. And developers try their best to assume what people will be looking for, but it's not always the case. So my point was that unfortunately in practice, even when you are perfect with performance schema, you may not be able to use it for one of the reasons listed. And this is what I found in practice already when working in MariaDB. So I had a very practical hang, like queries, single row lookups by primary key, spending 13 seconds, for example, at some high enough concurrency. Yes, just to get a row. Why? The plan is perfect. The stages of the statement are clear. Okay, a lot of time is spent on some stage called statistics. What does it mean? What statistics to get there and why? I mean, what do you need to decide on the plan for single row lookup by primary key? And stuff like that. It was also complicated by the fact that it was all working in Galera with concurrent updates and all kinds of stuff. So we spent maybe many weeks trying to capture all kinds of details from performance schema to see just things we already know. So the time is spent in some cases in statistics stage. There is no wait for any files on disks or whatever. There are no bad plans or anything. So things like that. At that moment, I found out, I tried actually another approach that I was quite familiar with, but had rarely used. Actual profiling from the operating system side.
Right.
At that case, we already had a chance to use Perf profile. And Perf profiler allowed us to find out where exactly in what function calls up to the source code function calls the time is spent. And we found out that it was spent on, quite obvious probably right now, on random dive to the key in the primary key. It's not strictly needed. We know that at most we may have one row with a specific key value, but random dive still happened. And that random dive had not happened in time because there was an artificial limit set on the number of InnoDB threads that could be run. So starting with some concurrency, even simple queries had to wait for other updates or whatever concurrent query finish to just join the QE. Quite a simple thing, actually, and probably somebody could guess it. But what Perf gave me is that it gave me a way to see it. And that like turned me to this side of things. So when, for whatever reason, you do not get enough details from instrumentation scheme, I reported a bug to not put it this way onto a statistics stage to make it more clear. It's still verified and not implemented. So that's another thing. If I do not have the level of instrumentation I need, I wanted to get a way to add it, not into the code as developers do. I'm a support engineer. I need solution right here, right now.
Right.
So I started to check what Perf can do else other than that. And eventually I found out how it's implemented internally, that it's based on new framework that kernel developers in Linux added for themselves to solve their complex problem that actually allow to instrument entry and exit from every function. And for that matter, actually every executable assembler instruction by having a way to inject at runtime.
And so this is, that's really low level. Yep. And a lot of this work was kind of pioneered by Brandon Gregg, right?
Yep. So I found out, okay, I will surely give and already gave in my blog post the details of how it's implemented. Thing is, it's already there in Linux, starting from Red Hat 6, from 2.6 kernels. The framework is already there, and they added it in purpose because they were not able to quickly enough dynamically change the code when solving and seeing the problem that is maybe never repeated elsewhere by nobody else on the fly. So what I found out by reading the Brandon Gregg's blog post are not only examples, but the fact that they apply this approach, adding dynamic instrumentation just there at various levels for quite some time there in Netflix, at the amount of concurrency and load that is above and beyond the majority of needs of an average or even top customers that I have to deal with. So I had to study it more. I found out how it was initially included in Linux in a simple form of ftrace interface where you just write something to a text file to set up instrument and then read from another text file to get the metric. I studied how Perf works based on this framework, and then started to check what happens with the newer kernels and basically what else Brandon Gregg adds to his blog when they face new problems, and found out how to resolve them. Some of his examples are actually MySQL based, so it was natural to try that. So what I found out that Linux is evolving in this regard, and with new kernels, kernel series 4, starting from 4.9 specifically, and kernel 5s, what we see in current Fedora, and what will be the future in enterprise Linux is soon, if not yet. So they went a bit farther. One thing is to add dynamic probe or get information somewhere, but you have to collect it and you have to process it. Collecting it, usually by Perf, for example, means writing it down to the file system in a user space. And writing to a file system slows things down because it's still a write. And it may be a huge amount of information to post-process. So you do not get the immediate view of what happens. So what Linux kernel developers did, and actually Windows did the same under another name, modern versions, they provided a way not only to add probes, but to add some programs, so-called BPF, eBPF, extended Borland packet filter interface, eBPF programs that are from one side are executed in kernel context, and, and from the other side they are safe. Tools like, they cannot crash your kernel, they cannot crash your application, they are safe because there is a virtual machine running and there is a check for safety, so it does not execute instructions that can break, it's kind of isolated. So next versions added the ability to actually pre-process the data and export to the user space via context switch only an aggregated data. So that's even more lightweight monitoring. So you can get trace, you know, even by GDB or with debug binaries. The question is the impact on the thing you are studying. As a scientist, you understand that when you study a thing, you interact with it. And when you study it, you already change it. So the smaller the change, the more correct understanding of the problem you have. And that's what modern Linux gives us. And that's why I decided to summarize this. And it was quite a process that started last year. I presented a talk at Percona Live Amsterdam to this regard, then added some information in additional blog posts. And for this upcoming talk, I plan to rearrange it and show not only how it works, not only the history, but maybe a quite recent application that I tried of the eBPF-based tracing, so the lightweight one with aggregation that is done in a BPF program, not elsewhere. And that eventually may be used, or maybe already used, you tell me, even in Percona Toolkit in PTPMP. So when you get traces, you can get it much easier with less impact than by attaching GDB without hangs or stuff like that. So I would like to show this way, and I would like myself to apply it as soon as possible. So whenever I see a new enough kernel and I see a customer who is determined and willing to help by providing the way to study that I ask about, I want them to try, and they try. And some of the customers are quite responsible and responsive to such requests. So I already get a chance to, for example, study the problems of thread pool implementation that hanged in some cases or works somehow unpredictably in practice by using these dynamic tracing approaches. I would like everybody to be aware about them, and they actually can be applied to any software. That's the point. I apply them to MariaDB and to MySQL. It can be applied to MongoDB, to Postgres, to Oracle database. It's especially easy to apply to software that you have access to source code, because you need to somehow understand where the variables come from, what variables you would like to print, if any, how to aggregate. You need to read the code.
So not only
not just guess, but it's like a universal thing, and it works already for kernel developers to make faster and more scalable kernels. So why not we, professionals who deal with applied software on this operating system, should not use that? We should, and we must. The price is already paid. It's already there in the kernel. You have do nothing. You do not need to report a feature request and wait for yet another instrument to be added. You can add it yourself in a safe way when you need it. And when it's not there, you disable it. The performance impact is zero, just nothing, comparing to not having this instrument at all. It's a great thing.
So not only can you help diagnose problems real time, but we can use these tools to help build better databases, better software, and make sure that the bottlenecks are taken care of without having the massive overhead of normal.
Yes, we have more chances to understand clearly what the bottleneck is, because with the lightweight instrumentation, our influence when we watch the system is minimal. We do not change the profile of how it works. By writing massive data to disk, if it's megabytes per second with a detailed enough profile, thousands times per second, you influence your disk I/O so much that you may mask the real problem or introduce more problems than you actually solve by such a monitoring. And then something will hang and you will be asked to get out of production server once and forever. The only simple problem with this approach is that in general it requires root or sudo access. So we need to cooperate with sysadmins, with the DBAs from customer side who have to do that for us or allow us to start these tools. That's the problem. And that's one of the reasons why in the blog post I say that I would like for wider IT community to be aware of this, because I would need cooperation from the customer side to get a chance to apply this. And when I have a chance to apply such approaches to complex problems, we get better understanding and we get more experience. I am getting more experience personally. I'm not working on Netflix. I do not have so massive systems to see the problem every time. And I am a bit tired on working on artificial problems that I model in my laboratory. I would like to see real problems studied with this framework and with these approaches. So that's why I decided to speak about it again. And thank you for Percona, to Percona for the opportunity to do this. even though the conference could be just canceled, the fact that you try to do it alive is great. And I hope to see new feedback, more feedback as usually happens after the conferences. That's great.
Great. Great. And, Valeriy, thanks for taking a few minutes to chat with us about this. We really appreciate it. And thank you for giving your time and energy towards, helping us, tune and make our systems better. I think a lot of people will benefit from this talk.
Thank you. I hope it's going to be a great conference, and I'm also waiting for other talks to listen. I see the program is quite interesting for the wide audience, and not only for MySQL people and not only to MariaDB people, with several databases covered. And I am sure that from each side we may get some unique approaches and experience that we can later apply to our specific cases. Thank you.